All right, let's just do a couple of these compound interest problems because there's not really much variety to them. Once you understand how the formula works, it's just a matter of plugging different numbers into the same places time after time. So here's our formula from last time. The amount we have after t years equals the principal, that's the amount invested, times 1 plus the rate over the number of compounds per year to the power of the number of compounds per year times the number of years. So if we invest $5,000, it's for 6 years at 12% compounded quarterly, the amount we'll have after those 6 years is going to be our principal. That's how much is invested. So 5,000 times 1 plus the rate's 12%, so 0.12 divided by the number of times per year. Quarterly means 4 times a year. And then our exponent is going to be that same 4 times a year for 6 years. Like we talked about last time, we're going to be multiplying by something, and we're going to multiply over and over and over again. If we are doing 12% a year, 4 times a year, then we're really earning 3% each quarter. So 1.03. And you can do that on the calculator. Right? Just do 1 plus 0.12 divided by 4 and give the 1.03. And then for our exponent, 4 times 6. So we're earning 3%. And we're going to earn that 24 times, once every 3 months for the entire 4 years, or 6 years. And then we can type in 5,000 times 1.03 to the 24. And I suggest you do it this way. Instead of trying to type this into the calculator and having to worry about the parentheses, because you need parentheses here also, if you simplify those numbers first, it's much easier to deal with. And that gives us 10163.97. Sorry for the sloppiness. So our 5,000 over those 6 years has grown to $10,163. Let's do another one. Let's take just a few $100s at, let's say, 5% compounded monthly for, let's just go a few years, 4 years. Right? Or the amount we would have after our 4 years would be our principal, $300, times 1 plus our rate, 0.05, divided by monthly would be 12 times a year. And that would be 12 times 4. We're going to do it 12 times a year for 4 years. That'll be $3,000. And go to the calculator for 1 plus 0.05 divided by 12. That's going to give us an uglier number. You're going to have to use more decimal places than you probably would like here. When we're dealing with exponents, rounding your decimal places can be a bad thing because your answer will be off by more than you would want it to be. 12 times 4 is 48. So when in doubt, use more decimal places. I've got like 6 there or whatever. So 3,000 times 1.004167. So that means we're earning 0.4% each month over a total of, to the 48 power, 48 months. And that'll give us, yeah, you're probably shouting at the screen right now. I'm sorry, I said $300 and then I multiplied by 3,000 there. So I'll get rid of a 0 and that will get to 366.27. Right, that just makes a decimal point move there. So instead of 36.62, it'll be 366 and 27 cents. I think that ought to be enough to get you through the 5.2.2. Couple problems there. And then next time we'll look at some different, more interesting maybe, exponential problems.